Hello and welcome back to part 3 of computer auditing, general controls. This is going to also be a shorter video, so we're attempting to make videos as short as possible. Unfortunately, the last video ended up being quite long, almost an hour, but this video is definitely going to be a lot shorter than that. Let's get straight into it and look at what we are dealing with. So this agenda you guys know well. In video 1, we went over topics 1 and 2, which is where we discussed the components of the IT environment and the difference between general and application controls. Video 2, which was the big video where we discussed access controls, physical controls, and logical controls. That is a critically important video, particularly when we are designing different IT environments. And also what's important in that section is when we are looking for weaknesses in the IT environment, we need to refer back to our understanding of access controls. In this video, we are going to be dealing with the bottom 2 agenda points, which is program change controls and interface management and other topics. Let's get straight into program change control. Program change controls is dealing with when we are changing systems. So when we are taking out an old system and putting in a new system. Before we dig any deeper, we want to try and understand what the audit risks around program change controls are. From an audit risk perspective, the biggest risk for us as auditors is loss or damage of data. This is the thing that will result in our financial reporting being incorrect or us losing a lot of financial data, which we need to make management decisions. The other important risks that we need to take account of when we are changing from one system to the next is the cost of the system. The system can get very expensive, and the costs related to changing from one system to the next can actually be projected, and then later on when we actually are making the change, those projections can be overrun. So we need to be very careful around the costs that are assigned to changing from one system to the next. The next thing that is important is users' needs. So we change systems when the system is no more meeting the needs of the user. Either the environment around the entity has changed, which means we need to change the IT system, or the IT system is no more supported by the company, which means there's no way to recover it. There's the security, the backups around the system is not sufficient enough to keep supporting our needs. So we may need to change the system either if the environment has changed or if the system is no more adequate. When we change the system, we need to change it so that it meets the needs of our new users. The danger is that we can go through this process of changing the system and actually choose the wrong system, which means even the new system that is implemented still does not meet the needs of users. Now, that might seem like quite a simple thing. I mean, we're changing the system because it doesn't meet the needs. But then I say one of the risks is that the new system might not meet the needs. The problem is that there are many things that are taken into account when changing the system, such as cost, such as time frames, such as the accurate developer. And at all of these points, the needs of the user may not be taken into account or may be overlooked. And that will result in a system that is inaccurate and does not meet the needs of our users. The next thing is, because we are going to talk a little bit now about creating our own system, whenever you're creating your own system, a very big danger is if there's errors or bugs in the system. That means that we create the system, but there's something wrong with it. It doesn't work like it's supposed to work. Another thing that's important that we need to take into account, particularly from an audit perspective and from a financial perspective, is the financial controls. If we have poor financial controls, it means that the developer did not understand what type of internal controls we expected or wanted, and therefore he was unable to program it accurately. We also may have multiple systems running at the same time. So we may have, for example, the financial system, which runs next to and works with the operation system. If these two systems are unable to communicate effectively, we can have a breakdown of transfer of information between the two systems. This means that our systems are incompatible. The other thing that's important as the auditor is that when our client changes a system, it may mean that the new system is no more compatible with our audit software. A system is only as powerful as the people that are using it. So if we do not train our employees adequately, we can end up with a system that can do a large amount of things, but because our employees do not know how to use it, we then end up with a situation where the system is useless. The other thing that is becoming increasingly important in today's world is after-sale service. So if our system does not have adequate after-sale service, we may end up with a system that cannot be updated or changed in the future. In-house development. Now, just before we get into in-house development, I need to explain. When we are dealing with a system change, an entity is faced with two big questions or two big options. One is to develop their own system, meaning they create their own system from scratch. That would involve hiring or getting developers to come in and create a system for you, develop a system that is specific to your needs. That's option one. The next option is if we buy an off-the-shelf system, meaning a system that has already been created, possibly by a large entity, and we then use it in our entity. And we may be able to customize it, but we also may not be able to customize it. We're going to get into that a little bit later. So for now, we need to remember that in-house development is us creating our own system. What are some controls that we can have when we are creating our own system? First is standards. We need to identify protocol standards and developments that are used in developing new software. We need to implement those in our development phase so that when our software is developed, it's developed to the best possible international standards. The other thing is that many of the standards will be based on other legislation or other regulations in the world. When we base our development on those standards, we are automatically meeting the needs of regulation and compliance throughout the world. Project approval. When we are talking about project approval, we are saying, how do we know when we need to change the system? How does that approval happen? So the first thing is there needs to be a request. And as we mentioned before, whenever there's a change that needs to be done to a system, we have to have a formal, pre-printed, sequentially numbered, and also pre-numbered request form. The request form is filled out by the user. Sometimes, if it's a major change in the system, the request form can even be filled out by a director. The director will fill out a request form indicating the reason for the change and what needs to be changed. He may not be able to speak in the same language that developers understand or that developers talk in. So the way he describes the system and what needs to be changed may be very much based on his end user perception. This becomes very important later on when we are dealing with end user needs, because we need to be able, as the developer, needs to be able to look at what the end user wants and use that to develop the system. A feasibility study is when you go out as the developer or as someone who is looking to create a new system, and you understand if the system that needs to be created firstly is actually required. So is there a real need for the system? And then how much will it cost if we were to develop our own system, as opposed to buying an off-the-shelf system? The rejection or acceptance stage actually happens at a very high level in the entity. It will happen at governing body or board of director level, where they will sit down and discuss the request, understand what are the results of the feasibility study, and then take a decision to either change the system or to reject this request. And now we will assume that the approval is to change the system, so they accepted the request to change the system. Once the request has been accepted, the entity will now create a IT steering committee prior to development. This committee is charged to go out there and ensure that the development of the system happens to the best possible standards. They are the ultimate ones that are responsible for what happens with the development, and they are to ensure that all stakeholders are equally communicated to throughout the process. Project management. When we are talking about project management, we are talking about the exercise of someone managing and making sure that the entire development process goes through smoothly. Now, who are the people that are required to project manage this type of in-house development? It is the steering committee that was previously mentioned under project approval. So the steering committee is going to be the eyes and ears of the governing body. They are the people that are going to be going out there and managing this development of the new system. The first thing that is required by management is to plan out the process. They need to identify what needs to be done, what are the requirements and responsibilities of this task. Once they have identified a task list, so a list of tasks that need to be done, they are then able to allocate it to different staff members or even hire out and outsource the responsibilities to maybe an independent development firm. They also need to set deadlines for what needs to be done when and clearly indicate that to every stakeholder involved. Theirs is to continually monitor the situation and the development around the system. User requirements. As mentioned previously, a request needs to be placed for a system to be changed. And when that request is placed, it is often placed from the perspective of a user. So the wording and the way the things are described in the request may not be the way a developer or a technician may describe them. This makes it critically important for us to understand what the requirements are of the user. What does the user want to see coming out of the system? This will require a lot of discernment and a lot of perspective changes that need to be done when analyzing what the user has indicated in the request form. Now, there may be multiple request forms that need to be looked at. Not only that, when there's a major change in a system, all users of the system need to be engaged via a questionnaire or an interview to ask all users of the system what changes would they want to make and how can the system be made smoother, how can the system be made more efficient and more effective. Once all of that data is gathered in from the different users, there needs to be a second round of approval to review each of the requirements of the users and then approve what the final system will look like. Using the requirements of the users, we would then go down and document the specific specifications of the system. This means identifying exactly what needs to be programmed and when it needs to be programmed, and more importantly, how it needs to be acted out. What does the system need to do? Once that is done, we can go forth with programming. Once the programmers and the developers understand what is needed from the system specifications, it will be easy for them to program. So the developer will then go forth and program the system. After it has been programmed, it will be handed over to the steering committee, who will then start testing it. When it is tested, each and every module or each and every part of the system needs to be tested separately and when its development is completed. This is because if one part of the system is developed, not tested, and then another part of the system is developed using the inputs from the first part, we can end up with a situation where the system itself will not be able to communicate to itself. So we need to test each and every system as and when it's developed. Once we test it, we can then be able to continue development. So this, between programming and testing, it's almost an iterative process. It goes around and around. We have different types of tests that we can run. For example, a program test is where the system is tested for bugs or errors. A system test is to ensure that all the programs work together nicely. An end user acceptance test is where we offer the system to the end user. This end user will then use the system and revert back or come back to us with any changes or things that need to be amended. Final approval. Final approval is after all the testing has been done and all the results have come back and they are all positive. Then directors, together with the IT steering committee, can approve the system for use. Once that happens, steering committee then falls away and no more becomes important. Training of the staff. Once we have developed our system, we need to have the directors, together with the developers, train each and every staff member that is expected to use the system. Notice that training should happen before we convert to the new system, so that when we do convert to the new system, the employees know how to use it. Then we deal with conversion. Conversion simply means we're stopping the old system and we're starting the new system. But there are different ways that we can do that. There are different methods that we can use. For example, the first method is parallel processing. That is where the old system and the new system work together or run together for a limited time. This may create a proliferation of work, meaning that an employee may need to enter the same journal entry into two different systems. Immediate shutdown. That is where we stop the one system and start the other system in one day. This is a very risky type of conversion. That is because if we do not stop the one system adequately and we haven't transferred all the data to the new system correctly, we can end up with incorrect or damaged data in the new system. However, the benefits of this system and the rewards of this type of conversion is much greater than the other conversions, because staff members do not need to enter information twice. The old system is stopped and the new system begins during the same day, which means there's no change in the way staff operates. Phasing. A phasing conversion is where we implement small changes in the old system, so that by the end of our phasing, the entire old system has now been removed and the new system is in place. Phasing takes a lot longer, and it can result in miscommunication between the old system and the new system. So a very important part of phasing is to make sure that the old system can communicate with the new system. And if that has not been taken into account during development, then we will not be able to use phasing as a conversion method. Preparing data is critically important before conversion, because different systems may use different types of data or different formats of data. So we take the data out of the old system, change it into the new format that we're using, and then input into the new system. This is called data cleaning. It is a very important part of the conversion, and without that, the conversion will not happen. Post-implementation review. This happens a few months after the new system has been implemented. We come back to it and review, has the system been working accurately? Has anyone had any issues with it? And what changes need to be made? This again is an iterative process, means that it does not just happen once, it will happen multiple times. Maybe 3 months after implementation, 6 months, 9 months, 2 years, 5 years after implementation, to ensure that the system remains relevant and continues to meet the needs of the user. Documentation happens throughout the program change. It simply means that every change or any programming that is done is clearly documented, so that in the future, if we need to go back and look at what we've done, we are able to do so. So that brings us to the end of in-house development. The next option that we have is to buy something off the counter. Off the counter simply means that we go and we buy a ready-made system. For example, you may be watching this on YouTube. You can either create your own software to watch videos, or we can use YouTube. That is the same type of example or the same type of decision that an entity is faced with. The difference is that if you watch on YouTube, you may not have all the functionalities that you want. But if you develop your own system to watch videos, you may be able to input specific functionalities that you may need. Many of you all will know of SAP, S-A-P. SAP is an off-the-shelf system. If any of you all have done any VAC work, you will see that many companies in practice actually do use SAP. It's an off-the-shelf system. SAP does offer some sort of customization. However, it will never be 100% customized to the entity. Let's look at the advantages and disadvantages between using packaged software or off-the-shelf software and using in-house developed software. The first advantage is that off-the-shelf software will have a much lower cost because we're not paying developers, which can cost a lot. We're not paying testers, and it happens a lot faster because all we need to do is buy it off the shelf and then implement it. Modern software packages come with a lot of software upgrades and a lot of technical support. Whereas if we develop our own system, because it will be unique to our company, we may not get that same sort of support and we won't get any upgrades until we request a change to the system. Disadvantages, however, is that because it's not fully customizable in South Africa, we may not be able to meet the regulatory requirements of the South African government, or we may not be able to meet the specific requirements of a given company. Because we cannot make any system changes or any minor or major changes to the software, we are limited in terms of what we are able to do with the software. Retirement of applications. Retirement of applications is talking to the fact that sometimes we have a system that is very old and we need to take it away. Part of program change controls is also retirement of applications, because when we are removing the old system, we are actually retiring that system. Retirement of applications is to make sure that applications or software that is not used anymore is removed safely from the entity, does not cause any damage during the removal, and any data that is contained on that system is not lost. Now, when we talk about retirement of applications, we're talking about both hardware as well as software. It is very important to identify what are the costs and the benefits to retiring software. For example, the older our software and hardware gets, the more maintenance costs it will incur. By retiring that software, we will save a lot on service costs and maintenance costs, but we will incur a very big initial cost of replacement. So understanding and doing the cost-benefit analysis between those two things is critically important before we retire. The other thing is new technology will increase efficiency and effectiveness in our entity. So when we're retiring an old system, we may be able to gain a lot more efficiency from using a new system, which may mean that our labor is more productive. Those are the quantitative benefits and costs. The other thing that we need to take into account is the qualitative benefits and costs. One of the new innovations in technology has been cloud computing, meaning that whatever we do, we are able to save it somewhere on a portion of the internet, and we can access it from any device and at any time. This has been revolutionary because we previously had never been able to save things on the internet and then re-access them. We need to also be very careful to make sure that whatever software we retire does meet the requirements of legal and regulatory requirements. This means that if we have data that we need to keep for example, 7 years, by retiring the software, if we're going to lose the data, we should not retire that type of software. Before retiring software, we need to find a replacement for that software. So identifying the software that we'd like to use, if we are going to in-house develop it, we also need to identify that before we retire the old software. Oversight of controls is critically important because we may have good controls on the old software. By retiring it, we may lose some control, or we may actually improve our controls by retiring old software. Some risks that we must consider. The risks are very similar, you will notice, to program change control. The first is loss of data. We can often lose data by retiring old systems, data that may not have been copied or backed up. It may take a lot of time to retire old software, and we may need to train our staff on new software. This is a major risk. Retiring old software may result in the software not actually being removed entirely, but just being dormant. This means that someone can still access it. You would know that regardless of whether you delete something off your cell phone or not, it's still a portion of it still remains active on your cell phone. For example, every photo that you've put on your cell phone, a small portion still remains on your cell phone even if you've deleted it. This same thing can happen with software, where a small portion of the software can remain active even if it's decommissioned and is not being used anymore. This can open up our company to additional risks of hacking and damage. Next, we want to talk about interface management. So what exactly is an interface? An interface is actually an imaginary barrier between two components of a system. For example, we might have one computer system that we run the GL on, and then a separate part of the system also runs the debtors ledger. These are two distinct components of the system, but the GL needs to communicate with the debtors ledger, and the debtors ledger needs to communicate with the general ledger. So these two components have to interchange information regularly. The break between those two components is called the interface. Simply put, an interface is the part where one component of the system is communicating or discussing something with another component of the system. For example, you looking at your laptop or cell phone is an interface. You are a component of a system. As a human, you are a component of a system. The next component is the hardware or the laptop that you are looking at. The communication between you and your laptop needs to happen with a free flow of information. If, for example, your screen is cracked or your screen is dull and you cannot see anything on it, that means there's a break in the interface between you and your computer. Interface management then is the management of activities and the identifying and controlling of the communication between an interface. As the auditor, this becomes critically important because when information is being communicated from one part of a system to another part of a system, we want to ensure that the transmission of that information happens accurately, happens validly, and the information that's transferred is actually complete. End user computing. End user computing simply means the part of the system that the person that is entering the data in sees. That is end user computing. So it is not the program, it's the non-programmer's part, the part that the user sees. The risks that can come out from end user computing are the following. If someone is using a system and does not continually back up what they are using, they can result in a break of information. Poor security, such as not locking your laptop before you leave, can also result data can be leaked or damaged. Users can actually override or ignore controls. Users can also create errors in a system. Documentation. So throughout today, we've spoken about a number of different things when we are wanting to change the system. But all of the things that we spoke about over the 3 videos, changing the system, backing up the system, disaster recovery plans, understanding what our access controls, we need to document all of that in the IT department, into IT manuals. These are critical manuals that need to be accessed freely by IT department members and sometimes even other members outside of the IT department. So documentation has to happen and the documentation has to be accurate. Documentation will result in the development of an IT policy, which basically means what users can and cannot do. It may also result in training and new processes that have to be undertaken by users. These are all critical, and if we don't document things correctly, we will not be able to identify the responsibilities that come out of the documentation. Thank you. Even though this is video 3, this is the first part of a 2-part series called Computer Auditing. Please come back next time and watch the next 3 videos on Computer Auditing Advanced.